All right. I'm not a great artist, and all of you know that. You've seen my drawings too many times in geometry. But one thing I loved learning when I took art in high school was what perspective drawing was. How do you make something look like it's going into the distance, and how using parallel lines and perspective points made a difference. And I actually enjoyed making what was called a double perspective, two-point perspective idea. And it was a lot of fun, but I wasn't good at it. I tried. But this is an example of when we're not going to be that exact, and an artist probably wouldn't be that exact either, but the idea behind the art of being perspective drawing. And I like this word problem for that reason. It says the following. Suppose that an artist decided to make a larger sketch of the trees in the figure. If AB, and this is the segment right here, so remember there's A, B, C, and D. Down below, and I think you can see a little bit easier on your paper, is going to be K, L, M, and N. If AB equals 4.5 inches, and BC equals 2.6 inches, and CD equals 4.1 inches, and KL equals 4.9, and these are all been labeled for you. Find the length of segment LM and MN. So I'm looking for those, and so I'm going to call this one X, and I'm going to call this one Y. And I think you can see it a little bit more. But here's one thing you're going to have to assume. They're going to give a natural assumption that these trees are all parallel. And that's just using the basic idea of if I could pick the trunk, it would be a basic straight trunk. Just gives us a perspective drawing behind that a little bit. So all those trees would be parallel. Well, that's using it like our last theorem. I should be able to set those up. So I do. I'm going to set up using this part to solve for X first. Okay, so I want to solve for X first. And the cool thing is they gave me decimals, so you can go ahead and use decimals in your problem. So if that's the case, I'm going to go like this. AB is to BC as KL is to LM. So I'm going to go 4.5 is to 2.6 as 4.9 is to X. So I'm going like this, kind of like the top to bottom idea, but it's on its side. So I'm going in that direction when I do it. So now I'm just going to go ahead and cross multiply. So I get 4.5 times X equals 2.6 times 4.9. Now some of you are going like, Mrs. Gregerson, what if I went the opposite way? Okay, you're good. You'll still get the same answer. So I get 4.5. Actually, let's just divide by 4.5. It'll make it a lot easier and let you do that all on your calculator. And if you do it all on your calculator, you're going to get 2.8 inches. So right here, I don't know if you can see that real quick. There's X. LM is 2.8 inches. Now that will help me draw that, so that helps a little bit. But now that will help me solve for Y. And I'm going to do the same type of idea here as I did the last one. I'm going to go like this. BC's here, and I'm going to move, going the same way. So let's do the same thing. I'm going to go left to right. So top is to bottom. I'm going to go 2.6 is to 4.1 as, I'm going to go the same direction here, left to right, as 2.8, which we found, is to Y, which is MN. So I just called it Y just to make it a little bit easier on ourselves. So then we're going to cross multiply. We get 2.6 times Y equals 4.1 times 2.8. We're going to go ahead and divide by 2.6. So that way and these simplify out to be 1, you know, and I was at a conference and they yelled at us for, say, canceling. So we'll say simplify. So then we go here and you punch it in and you get 4.4 inches. And X was been 2.8 inches. So this one was LM. So I should probably put it in there. And we know MN was 4.4 inches. So we're putting in the right links when we do those. Hopefully that helps a little bit more on this one. All right, and the next one I kind of am excited about because this one is just fun to say. It's called the triangle angle bisector theorem. Isn't that fun, the triangle angle bisector theorem? Okay, if I was in class, I'd probably dance to this, so just watch out. You know, hold yourselves back on this. This one kind of makes me think of the geometric means, but it's like it's forgetting there was right triangles involved. So here is the big thing. This doesn't work for the triangles down below here, okay? It does not work for the right triangle one. And that's a common error I've seen on quizzes and tests. Did everyone hear me? This diagram and this one are not the same thing. There's not right angles in there, so be very careful. All right, so here's the definition of this one. An angle bisector of a triangle. So here's the angle bisector, so AD. Those two are going to be the same measure. Divides the opposite side into two segments whose lengths are proportional to the lengths of the other two sides. Basically, what it's doing is dividing segment BC into two segments that are proportional with these. So those two are going to be proportional, and these two are going to be proportional. What it does, it kind of acts as a divider of doing these. And there's more than one way of setting up this one again. And again, I don't really care which one that you do, long as you go the same direction again. So the one that I kind of like best, and actually have it in my notes, is the second one. I'm going to do it this way, is let AD, the angle bisector, be kind of a divider that divides it in half. And you know, these two go together and these two segments go together. And so I'm going to go AB is to BD. So I'm going this direction, I'm going down. And that means I'm going to have to go down again, as AC is to, in this case, it'd be DC, okay? So AB is to BD as AC is DC. Now, or use the invert. So you could go bottom up. And so it doesn't really mean, so invert the proportion. It doesn't matter, it's the same proportion. Or, this is how some people do it. They like use AD as the divider, and they'll go, oh, AB is to AC as BD is to DC. And the problem is, when I give you two choices, you have to really decide which ones go together, but you have to make sure you're going the same direction. So this is one of those times that if you do your homework and you're not sure if an answer is right, call me. I do think I gave you some odd-numbered problems for that reason. Make sure that you check your work in the back of your book. There are answers back there. All right, let's look at the next one. It says, find the length of segment PS and the length of segment SR. So we're not just solving for the variables, we're going to have to plug it back in or substitute our value back in to find our length. So looking at this one, how in the world would I set this up? Well, the first thing I look for is, do I have an angle bisector? Because I can't use my right triangle one. I can't use my geometric mean stuff that we did for like lesson 8.4. They don't work together. So I look at this and say, all right, how can I do these? Well, you decide how you want to set it up. I kind of like using the fact that the angle bisector is a divider, and I would probably have gone like this. 32 is to x minus 2 as 40 is to x plus 5. So I get 32, I'll use a different one, I don't want to use that marker. So 32 is to x minus 2 as, now notice I go the same direction here, 40 is to x plus 5. So when I do this, I'm going to have to cross multiply. So I get 40 times x minus 2 equals 32 times the quantity x plus 5. Go ahead and distribute. You get 40x minus 80 equals 32x plus 160. Now this is where we're going to be good at our math. I'm going to add 80 to both sides. 40x equals 32x plus 240. Subtract 32x from both sides. I get 8x is equal to 240. Divide by 8. X is equal to 30. So I like that a lot. And so then we just plug this in and go, all right, segment PS, if I plug it in, that's going to be 30 minus 2. That equals 28. And then for our next one, we have segment SR. And that's going to give me what? 30 plus 5, because I have to substitute it in for x here, and I get 35. Now, just a sidebar with this one. If you don't like how that's set up, there's another way of doing it. I kind of like this way of doing it too. Let this be like your equal sign, and then you go this way, okay, over it. So you go, actually I don't want to say equal sign here. I'd probably say like your fraction bar. So you'd go x minus 2 is to x plus 5 as 32 is to 40. If you do that, what that allows you to do is to simplify that fraction, but when you cross multiply, notice 32 still gets multiplied by x plus 5. 40 still gets multiplied by x minus 2. So that's just an alternate way of doing it, and I really don't care which way you do it, as long as you get the right answer, okay? Now, this would be the time in class where I'd be like, okay guys, you can go ahead and do this on your own. And I don't care that there's fractions in it, I don't care there's decimals, you can keep decimals if you want. I know, don't have heart attacks, I just gave you permission to use decimals. But it's up to you to decide how you want to set it up. And again, I kind of like, and I'm going to go back to the way before, is I kind of like remembering, oh yeah, that's an angle bisector, so this is a divider for me right here. And I'm actually going to divide it like an equal sign. That means these two are going to have to go together, and those two have to go together. And I'm just going to say, okay, I'm going to go top bottom. 8 is 2, 4.5, as y minus 2 is 2. Y over 2. Ooh, fraction, panic attack. Oh, Gregerson, what do I do? Well, breathe is the first thing that you do, okay? And then you cross multiply. Because does the math rules really change? No, we can cross multiply. So when I do that, I'm going to get over here, 4.5 times y minus 2 equals 8 times y over 2. I'm going to go ahead and keep working with it and simplifying it out. I'm going to distribute 4.5. So I get 4.5y minus 9 equals, well, 8's divided by 2. That's 4y. So then I go ahead and I subtract 4.5y from the other side. So I get negative 9 equals a negative 0.5y. All right, let's the math do the work for us. Divide by negative 0.5. Yes, I just gave you permission again to use the decimal. Remember, decimal already in the problem, we're not going to fight it. So what do we get? We get y is equal to 18. By the way, 0.5 is the same thing as 1/2. It's the same thing as dividing by a fraction is multiplying by its reciprocal. Negative divided by negative is positive 18. So now I plug and chug it in. I have segment AC is what I'm looking for, so I got to get 18 minus 2, which is 16. We have segment DC. I'm going to get y over 2, that's 18 over 2, that's 9. Hopefully that gives you some help on these and gives you examples of each one. Please be careful not to use right triangles with this one, okay? A lot of people try to confuse that and it would not be correct. All right, guys, have an awesome, awesome day.